Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will show you how to use Excel to do a simple linear regression analysis on bivariate data, and this video should be very helpful when you guys are ready to work on activity 4. Okay, let's take a look at what we have here. We have a set of data that contains information about mortgage interest rate and median home price for a certain region over 15 years. And we would like to see if there is a linear relationship between these two variables. So we're going to go ahead and answer all of these questions here. Some of them you are already familiar with. And then I'll show you a quick way of computing many of the characteristics of this data. Okay. Let's go ahead and get started with the first question. This one says, construct a scatter plot using the data with mortgage rate being the independent variable. So you already know how to do that from chapter 2. We're going to highlight these two columns, go to Insert, Chart, and we select the first type of chart. Okay, so here's your scatter plot. You can take a look at it and see if there is any trend going on here before we make any sort of conclusion about it. But it looks like the higher the rate is, the lower the median price is. Okay, not exactly a straight line, but you can see that the home price increases with the mortgage rate going down. Okay. All right, so here's your scatter plot. That's done. The next question is compute and interpret the sample covariance. Okay, you already know how to do that one too, but let's go ahead and do it anyway. So that would be covariance. And since this is a sample covariance, we need to do .s. Array 1 is mortgage rate. Array 2 is the median home price. Here's your value, okay, and what's the interpretation? There is a negative relationship, right? If the value is negative, over here, that means there's a negative relationship between the mortgage interest rate and median home price. Okay, just to remind you, covariance tells you if the relationship is negative or positive. What about correlation coefficient? This value will tell us if it's a strong or weak linear relationship, right? Okay, so let's see. What are we going to do here? We're going to go ahead and say this is equal to correlation coefficient. This one you should also know from previous chapter. Same as before, we're going to highlight the first column, second. There you go. And here you have negative 0.62. So that's not a strong linear relationship. I'm going to go ahead and say weak to, or moderate to weak. Negative linear relationship. Just to remind you, the stronger the relationship, the higher the coefficient will be closer to 1 or negative 1, right? So in this case, it's not exactly close to negative 1. So, and you might be asking me in this question, is there a way to really determine if the linear relationship is strong? The answer is yes, but we're not ready to talk about that procedure just yet, okay? But there is a hypothesis testing about the slope of the linear model, and we will be ready to talk about it once we cover hypothesis testing. Okay, so this is what you have so far. So let's see, we've done this part here, we've computed the sample variance and sample correlation coefficient. Okay, so that's done. So describe the relationship between the mortgage interest rate and the median price. So what would I type here? I would say the higher the mortgage rate is, the lower the median home price is. That's a reasonable statement. I don't want to say that the relationship is linear just yet. Okay, we're not sure if a linear relationship is appropriate here. Okay, and this coefficient suggests that maybe not. Okay, it's not close enough to -1. Nonetheless, we can still come up with a model, with a linear model for this set of data. Okay, determine the least squares regression line for this data set. Okay, now let's go back to our scatter plot. And if you click on the dots and then right click one of them, you can go ahead and select this option right here, add trend line. And we're going to pick linear and also check display equation on chart. Okay, so there you go. Here's your equation. Oh, I want to move it over here so we can see it a little better. Okay, so here's my equation. Let's go ahead and write it. Y is equal to -23409x plus 393349. Okay, and these numbers they're actually rounded, but that's okay because we're dealing with dollars. It's okay to round in this case. All right, so this is our equation, the least squares regression line to fit this data, meaning what? If you were to compute the distances between the values on the line and the actual data, which we're gonna define later, then this line would be the best fit, meaning the error overall would be the smallest. Okay, so that is your least squares regression line. You never have to do this part by hand. Okay, and I'll show you another way of doing it. So this part is done too. Okay, so far we got this part. Okay, interpret the slope of the equation from the step above. In other words, what does the number mean in the context of the problem? So here I would say the following. Here's my slope interpretation. Okay, what happens here? For every 1 unit, as we move to the right on the x-axis, the y changes by whatever the slope is, right? So in other words, we say for every 1% increase in the mortgage rate, what do we have here? The median home price decreases, right? Because of the negative. Oh, can't spell today. Decreases by how much? Well, by this number, $23,409. That is your interpretation. Okay, for every 1 unit on the x-axis, the y value changes by whatever the value of your slope is. Okay, so if it's negative, it's decreasing. If it's positive, then it's increasing. Okay, that is your slope interpretation. All right, next question. Use the regression line to predict the median home price if the mortgage rate is 5.5%. Okay, so I'm going to put it right here. So how would I do this? This is equal to -23,409 times 5.5, right? And plus 39,349. Okay, I'm just plugging in 5.5 into this equation right here. So let me highlight this in a different color. So here's my equation, and this is what I get. So let's just check if my rate is 5.5, then this is the value of the home, so of the median price, right? So that's what we get over here. So that's all you gotta do here. Okay, just plug in the value of the independent variable that you're asked into the equation. Okay, now the next question says find the residual value when the mortgage rate is 8.4 and then 6.5 for the next question. Did the model overestimate or underestimate the median home price? Okay, so to find the residual, the first thing that we need to do, we need to actually find the predicted value, okay? So I'm just going to go ahead and drag this down, and that will copy my equation here, so I don't have to retype it. But once I go back into the cell, I'm just going to change 5.5, and I'm going to change it into 8.4. Okay, so if my rate is 8.4, then I get this value right here. And then if it's 6.5, so let's change this number to 6, I get these prices right here. Okay, so we're not done with these parts just yet, because then it's also asking us to find the residual, right? So what is the residual? Just to remind you, residual is what? It's actual value from the table minus the predicted in this order. Okay, the order matters. So residual is actual minus predicted. So what is the actual value of the home price for the rate 8.4? So I'm gonna find it. It's this guy right here, and then minus what? Minus the predicted value. Okay, so we get negative $23,513. Okay, let's compute this residual as well. So 6.5, I'm going to find my value in the table. 6.5 right here, 309,800 minus predicted. We get these numbers. So over here we get a negative number. Over here we get a positive number. So what is our interpretation? Did the model overestimate or underestimate it? So let's see if it's actual minus predicted. Okay, actual value minus predicted. If the difference is negative, then the actual value was lower than the predicted. So that means the model overestimated the value. Okay, same type of deal over here. This number is positive. If the actual minus predicted is positive, then the actual was higher than the predicted. That means the model underestimated. Okay, so that kind of gives you an idea how good of a model this is. Okay, so it's underestimated over here by a lot, $68,000, right? It's overestimated by 23. Okay, it's still not a little number, right? This is mortgage, so anything over $1 probably is significant. Maybe not $1, but 23,000 is definitely significant. Okay, so we found the residuals. The next question is construct the residual plot for this data set. So one thing you could do, you can compute these values for every one of these years. Okay, so compute the predicted number for each of the mortgage interest rates, and then find the residual, and then plot the mortgage interest rate versus the residual. Okay, and that will actually take you some time, so we're not gonna do that by hand. We're gonna do it by doing one function that will produce most of these numbers. So this is all I'm gonna do for this part. And now let's go ahead and construct the residual plot for this data and answer all these other questions 1 through 9 by really quick command. So let me go switch to this tab right here so we don't have our data sets overlapping. And what I'm going to do now is the following. I'm going to go to data analysis, and we need to go to regression. For the Y range, we're going to choose the median home price. For the X range, that's your independent variable mortgage interest rate. I want to see labels. Output. Okay, let's go ahead and put it right here. That's where you want your output to be stored. I would like to see the residuals and the residual plot. Okay. No, what just happened? Oop. Oh yeah. Okay. I need my y values. I overwrote them somehow. Okay, the output will go here. Here we go. Let's just check. The y range C, the input for x is B, output range is E, looks good. Okay. All right, so here's my plot. Okay, here's my residual plot, and here are all these other numbers that we've already computed. Okay, this number right here should look familiar. This is your correlation coefficient, but it's not negative, right? So we just know that the linear relationship here is negative, so but this number is exactly the same as we got over here. Okay, let's see what else. Here your coefficients for the equation, they're just not rounded, right? So here's your y-intercept and here's the slope. So this is how you would read this data. You would read this output, say, okay, that's the value of the slope that goes with x. This is the y-intercept. So my equation is y is equal to negative 23409.4 x plus this value right here, 39334.8.6, right? So this is a little bit more exact than what we had over here. Okay, let's see. So that's your equation. Here are all of your residuals, and you'll notice they're really close to what we've computed. Over here we used whole numbers, so they will be slightly off. So let's say for the residual of 6.5 we had 68,610, right? And over here it's 68,612. So we get a little bit more accurate result here because there was no rounding over here. Okay, but you see that you get all of these other values. You get t-stat, p-value, lower 95, and all of these values that don't worry about it for now. We're not ready to tackle this information just yet. Okay, so what I need you to know is how to do is find the residuals either way, either by hand or doing this output. Find the residual plot. Okay, and the residual plot is used to analyze the data and see if a linear model is appropriate. Okay, so again, we are not going to do it just yet, but here you also see that you have your coefficient and your residual plot. Okay, so I think this is it. So we've done everything that this question was asking. I hope this was helpful for you guys. If you have any questions about this topic, just reach out to me via email. All right, thank you for watching.